Hello everyone. Good morning.
Good morning.
Yeah. So 16 people have joined so far. Okay. Hope all of you are able to access the Google Drive. I have uploaded the PPT.
Hello. Hi, Sylvia. Could you please share the Google Drive link with once again? I dropped
Okay.
in between yesterday.
Okay. And this is the link. Okay. So let's start with a simple quiz on whatever we have seen so far in whatever areas that we have touched upon yesterday. So based on that only, all these questions are. So this is an MCQ pattern question. So just select that and submit the form. It's a simple Google form, which you had have seen earlier also. So just give me a sec. I'll give the link. It would have been great if we have the polls and quizzes directly here, but it is not activated on this account. So that's why it's a Google form. Okay, so I have given a link here. I want all of you to open the link and there will be it's a simple form. You need to answer all the questions. And can someone quickly confirm whether the form is opening up for you?
Yes, Sylvia.
Okay, great. Please go ahead. Let's spend around some 5 to 8 minutes on this, not beyond that. So yeah, you guys can quickly start. And submit the form post answering all the questions so that I'll be able to see the answers here. The link is already shared, Sonali. It's there on the chat. You can just click on the link, but it opens the quiz. So for people who have joined with us just now, we are doing a simple quiz, and I'm sharing the Google form link again one more time on the chat. And take yes, guys, another couple more minutes, so please finish it fast. People who have completed, can you just put a thumbs up on the chat?
What did they say? Okay, done. Okay.
Fine, let's discuss the answers. So let me open my form. I could see very few people have responded. See, this is just like a knowledge check, just to check where are we standing based on what we have learned. So this is nothing to rate you on this course or something like that. This is purely for your understanding. Because I could see only 13 people have answered so far, wherein we have 21 people in the session. So please do make use of this quiz. Fine, let's start seeing the answers, okay, quickly. So the first question is, what's the default file storage system? So obviously it's a HDFS. I could see around 100% of you have, whoever has marked the answers, marked it as right. So that's the answer for the first question. Now the second one is, which of the following statement is not true about HDFS? Okay, so the thing is, the question is, what is the false statement among all these four? So I could see that some of you have marked the correct one as answers, which is HDFS is a storage layer. No, that's not the answer, because the question is a negation kind of question. So the option would be 3, which is HDFS performs parallel processing of the data. Got it? Fine. The next one is, what's the default block size of version 2? Again, remember, I'm asking the default one. Now you can customize it to whatever number you want, depending upon your architecture, depending upon the size of files that you're processing and the size of the cluster that you're having. But the default one is always going to be 128. Okay. And for a file of size 258 MB, how many HDFS blocks will be created? Now, what's the confusion here? It is basically 3, wherein the third block is not something which I'm going to completely use it. Like we have seen this multiple times, I believe, in yesterday's session. Even there were questions also, and while explaining, we have even addressed it. So I could see around 30% of you have marked the wrong answer, which is 2. See, 2 blocks are completely used. But the question over here is not how many complete blocks, it is just how many HDFS blocks will be created. So 2 entire block, and the third block wherein I will be consuming just 2 MB. Okay, hope that's clear now. And the next one would be, what is a master daemon service for MapReduce approach in version 2? The name is going to be resource manager. If in case you were there in the session or you would have seen the slide, you can answer this. There are few people who have mentioned it as name node. Now, please understand, name node is only for HDFS services, storage related services. Resource manager is meant for MapReduce. Today, we will be seeing it in much more detailed way. So the answer here would be a resource manager. Now, what are the possible negative scenarios that can happen in a HDFS workflow? So you guys have to select both the under replication and over replication. It's a checkbox kind of question, right? Not a radio button. So you can select as many options as you want. It is good that almost 60, close to 70% of you have marked it right, marked it both as the answers. So that's great. And does name node hold any portion or block of the file? Absolutely no. Again, we discussed this yesterday. And what kind of files are a best suit for Hadoop? Like which kind of files can be perform at its best or is an optimal one when it comes to Hadoop? Obviously, smaller number of big files. Now, when I ask this question, if you're not able to understand what do we mean by smaller number of big files or larger number of small files, simple. Just imagine like this: 100 files of 10 MB or 10 files of 100 MB. Now there is a difference, right? At the end, both of them are close to 1 GB or 1000 MB, right? But you can generate that 1000 MB of data in two forms. Either I can have 100 files, each are of size 10 MB, or 10 files, each of size 100 MB. Now, considering the memory, both are same. But then which one can do its best when it comes to Hadoop? Obviously, this whole framework is best suited for bigger sized data. So obviously you need to go ahead with smaller number of bigger sized files. So 10 files, each of size 100 MB would be the correct answer. Able to understand that question, guys? It's not something we discussed, but I want you guys to think logically and answer for this question. Is there any doubt on that part, that question, specifically on that? Because, but I could see around 70% of you have marked it as the right answer, which is great. But for the remaining 30%, I hope it is clear now.
Sylvia,
Hmm.
can you please elaborate slightly like why the smaller number of bigger files
Sure.
are best suited for Hadoop?
Sure. This is one of the very common interview question also, by the way. So if in case, I'm not segregated it just for the sake of interview, but then it is something that you need to be aware of when you say, see, you should understand something like whenever in a cluster, so you have a cluster, you are sending back the responses, right? When you're sending back the responses in the form of heartbeat signal, what does a heartbeat signal carry? Suppose this guy is slave node 1. So he is saying, see, I'm slave node 1. I'm holding the blocks A and B of the file F. Now, similarly, I'm also holding, let's say, P and Q of blocks of the file F2. Similarly, F10, some X and Z block of F10. Like this, it will hold all this information, and this entire information will be shared, will be compressed and shared as a heartbeat signal to the master. Now, the same way, every node will keep on being sharing such heartbeat signal, though it will be in a compressed form, but then by time, right? Over time, when the cluster is completely busy, too much of data is there, don't you think this information grows really exponentially higher? Because the more amount of data that slave node is going to keep, the data which goes to your master node as a form of heartbeat. So technically speaking, you can call this as metadata, because it's not the data as such, but it's an information about the data, which is I'm holding A and B of file F, P and Q of F2, X and Z of F10. Like this, the entire information is shared. Now, the more number of blocks that are coming to you, see, when you will be getting more number of blocks, obviously when the size of the file is really bigger. But if suppose I am giving you 100 files, please observe this carefully. Each are of 10 MB. So 1, 2, 3, all the way up to 100. But everything is just 10 MB. Now tell me how many blocks each of these file will occupy? How many blocks each of these file will occupy? Come on, whoever has asked that question. Why 10 blocks? One file is of size 10 MB. So how many blocks it will need? What is the size of one block? 128 MB. So one block. So don't you think for 100 files, each are of size just 10 MB? But at the end, I will have 100 blocks. Now, what is the side effect of it? The more number of blocks, I know a block can hold up to 128 MB, but I'm not making the best use of it because the whole file size itself is 10 MB. And hence, in a block, I'm only consuming 10 MB, and that block's information I have to maintain inside the metadata. So over a point of time, your metadata keeps on grow, and that becomes certainly a challenge whenever we are sharing a heartbeat signal. The kind of data that I'm going to share becomes really huge. Now, this will slow down. Eventually, this will slow down the overall performance of your cluster because the data transfer will take more time. So you need to understand all of this in order to answer this question. Or in a way, simply what you can understand is the whole framework of Hadoop is meant for handling bigger sized data, right? I cannot go ahead and keep files just out of 10 MB, which does not make sense. Though it can handle it, your Hadoop cannot prove its efficiency when you are doing this. Able to understand now? Who asked that question?
Yes. Silvia,
Okay,
yeah.
great. Okay, please understand all of this because see, it's a simple, it's an implicit understanding when we are learning big data. We should be aware on all of this so that it helps us. Great. And the final question is the file in HDFS that is smaller than a single block size will occupy only the size it needs and not the entire block, which again we even discussed now. So I'm having a block of 128 MB. I'm giving it into a file, but that file itself is of just 10 MB. How much ever I need, I'll take. The remaining is going to be freed up. Okay. It's not going to occupy the full block size, right? I could see 2 people have marked this as answer. No. Why we need it? Because we need only 10 MB. I don't need to completely utilize the entire 128 MB. Great. Hope this is clear to all of you. Great.
Can you explain one more time the last question? No, not last. What are the possible negative scenarios? I missed that question.
Possible negative scenarios we discussed under the HDFS workflow yesterday,
Yes.
right? So what are the different scenarios which actually makes your name node to come up with an algorithm? So there are only 2 possibilities. Either your replication factor becomes lower or your replication factor becomes higher, right? So these are the negative situations that can happen whenever we are replicating. That's what the question has been asking here. Among the 3 available, see, if suppose if you have a name node failure also or a data node failure, you have to select all of them. But in the given options, there are only 3, and among the 3, there is only 2 which you have to pick up as a negative. Yeah.
So the answer is?
Both under replication and over replication.
Okay, so I have select only one. Okay.
It's a checkbox kind of question, no? So you have to select.
Yeah.
Sylvia, what is the difference between node manager and name node?
Node manager is a slave process for your MapReduce activities, wherein name node is a master process for your HDFS related services.
So
Okay.
node manager is data nodes.
Node manager is, yeah, you can relate it with data nodes. They are not exactly data nodes. You can relate it somewhere to a data node. Guys, can you stop this cursor on top of the whiteboard? Just a second, I should be disabling that. Okay, so all of you are able to see the whiteboard?
Yes.
Great. So let's begin quickly. See, yesterday we have seen about MapReduce. Great. So now one important thing I want you guys to understand in that, okay? Because that is what is going to help us understand why we are moving towards Spark, or what is the challenge in your MapReduce approach. And this is purely in terms of MapReduce, not in HDFS. HDFS, we have studied in and out about everything, like what happens when a file comes, what are the negative situations and all this. Okay, fine. Now, this is master. Okay, this is your slave 1, slave 2, slave 2. Okay, now just imagine what happens as we have discussed yesterday. Imagine the file is there and it is having 3 blocks located inside. So I have A, B, and C, and there is a Python code coming in. Okay, there is a PY code coming in. So what is a master is basically doing, which is resource manager, what is it basically doing? It shares the program to all the system, correct? So it shares all the code to all of the systems. So basically what happens, the slave node S1 will apply the program on top of this block residing under S1 and it generates an output. Right. So all these areas we have seen yesterday itself. Now, one important thing here you need to understand where this intermediate output will be stored. Of course, it is getting calculated on the respective slave nodes. Now, every slave node will have its own configuration. There will be a HD, there will be a RAM. Now, what happens inside the hard disk of this particular S1? Imagine this is the hard disk of your slave node 1. It will go and store this OP1. It locates a sector wherever we have enough space, and it stores this intermediate output inside. So basically, where this intermediate output is stored, it is stored inside the HD of every single system. Now, once all of the system individually have generated the output, that is when reduce phase will kick in. Now, who will do the job of reduce? The master will identify any one of the slave node, obviously whichever is having enough processing power. Now, I'm just assuming S2 is having enough processing power. So what is the master is saying? Hey, S2, go ahead and do the job of reducing. Because right now, all these guys have generated their output. Go ahead and read it. And compress it and give me as in one single output. Now, what happens? These intermediate outputs which are present on the other slaves, right, S1 and S3, they are stored inside the respective HD. Now, how we can read it? Of course, there is a disk read which will be involved. So, S2 will try to read OP1 from the hard disk of S1. Similarly, S2 will also try to read OP3 from the hard disk of S3. Of course, OP2 is available within itself, so there is no separate disk read will be involved. But disk reads are basically involved in order to do the job of reduce. Okay, so how many disk reads so far is happening? Overall, there are 3 blocks and 2 disk reads are happening. Right? Because 2 intermediate outputs I have to read from separate systems. Now, just imagine this is only for 3 blocks, which is very, very small. Now, when you go to industry-based scenarios, when you start working with files of GBs or TBs, obviously we end up in having too many blocks. And what's the biggest challenge here is when there are more number of blocks, more number of disk read operations will happen. Now, what is the biggest challenge when your disk IO is becoming higher? Can someone tell me? What will happen in a framework if I start having too much amount of disk IO operations? What will be the major drawback? Exactly. Performance gets reduced. Slowness, right? The entire processing becomes slow. Exactly. Latency. Now, this is becoming one of the biggest challenge of MapReduce. See, in order to show you guys as an example, to make it simple, I'm showing here with just 3 blocks. But nowhere in your industry projects, you will only work with 3 blocks. Minimum would be 50, 100, and so on. So in that situations, too many number of blocks, too many number of intermediate outputs, too many number of disk IO operations, which will eventually slow down the performance of your MapReduce. Now, this become one of the biggest challenge of your, this becomes one of the very, very biggest challenge of your MapReduce, and which makes us move towards some other approach, which can make this entire process really faster. So what is the biggest challenge of your MR? Now, too many disk IOs. For example, so I'll just give a number. For example, I'm having 3 blocks. Then in order to do the job of reduce, I will basically end up in doing 2 disk IO operation. This is only for the reduce, right? Now, before this reduce, I have to read it first, apply the code on top of it, generate the intermediate output. In those situations also, disk IOs are involved. But just for the sake of reduce itself, I'm having 2 disk IOs. So if there are n blocks, I will end up in having n-1 disk IO operations, and not for overall processing. This is only for the reduce operation of your MapReduce. Now, this becomes really a memory overhead, and it really hits the performance of any big data processing approach, which is involving MapReduce. And also, this is purely built only for batch processing. I remember somebody even asked yesterday when we learned about workflow, so how the same thing will happen for streaming data, real-time data. Now, this architecture is not going to support you streaming data. This is purely meant only for batch processing. So you have a file located in a drive. I can go ahead, read it, and process. If the file comes to you at a speed, no, your MapReduce cannot handle it because MapReduce is not designed for that. Right? But nowadays, most of the big data where the data is getting generated is also coming up from a streaming place. Hence, MapReduce cannot be used in all such situations. So got it? So these two becomes one of the major challenge of your MapReduce, which makes people think or people move towards some other framework, which really works efficiently by reducing the MapReduce operations. So first tell me, is this entire process clear? Any questions on this?
I have a question for
Mhm.
clarity. Yeah, when you were explaining the intermediate function process, so you use S2 as example. Can this be S1 or S3?
It can be anyone. That's why I'm saying if there are 3 blocks, 2 intermediate discretes will happen.
So if we have 50 blocks, so we
Hmm.
have, does it mean we have 49 intermediate blocks?
Exactly. That's what I have written here as if it is n, it is going to be n minus. Oh, if it is n, it is going to be n minus, right? So if you're saying you have 50 blocks, there will be 49 disk reads will happen for accessing the intermediate outputs generated on all of them. See, there can be a possibility. Also remember this thing also. See, we are talking about the worst case scenario. Imagine if a file is having, since you asked this, I also will explain that. See, suppose, as you said, your file is having 50 blocks. But just imagine 10 blocks are here, 10 blocks are here, and 30 blocks are here of that 50 file.
Sorry, I'm not seeing your screen if you are sharing.
You're not able to see? How about others?
You'll have to scroll down. If you
I'm on the correct place only. This whole whiteboard, you guys are able to view or not?
actually, it's a bit zoomed out, so either you have to zoom it out or
Okay, one
scroll it
second.
down.
No worries. Just how about now? I feel
Yes, okay, fine. Thank you.
okay. See, there is also a possibility. See, the one that we have seen earlier was a very worst case scenario wherein I have 50 blocks and I'm storing them in separate systems. But there is also a possibility if you have a 50 block, right, from one single file, 10 block can be here on this system, 10 block can be here on this system, and the remaining 30 can be here on this system. Now, even though when you are having 10 blocks, if the intermediate outputs are stored inside one single sector, then we are not going to take a huge seek time in order to read it. But the minimal operation here itself will also be, here there will be one complete discrete, here also there will be one discrete, here also there will be one discrete, provided all these intermediate outputs are stored together. But Whenever we learn about any algorithm or a framework, we should always think about the worst case scenario, because that will only give us a broader perspective. So if there are n blocks, at max, there can be a possibility of n-1 discretes will happen just for the sake of reading your intermediate output. Again, please remember, I'm only talking about intermediate output. Apart from this, we have a block to be read, and the code has to be applied on it, and we have to generate the output. So there also discrete is involved. So this n-1 discrete is purely only for accessing the intermediate. This makes the overall discrete operations really enormous, which slows down the performance. Got it? Okay. So now let's see how I'm going to handle this, right? So now the biggest challenge of MR is what? Too many disk IOs. Correct? That is one biggest challenge. And no real-time process or streaming data. Now then people have to come up with another framework such that these two challenges are sorted out. Now, what is that we are going to do for this? Again, I'm considering a cluster, but this time, instead of MR, we are going to talk about a new approach called Spark. Okay. Now, before even understanding what is Spark, what are the terminologies inside, I want you guys to first understand how it will behave in processing, because just now we have completed the MapReduce process. So now you can easily compare MapReduce with the Spark's approach of processing. Later, I'll come down to what are the terminologies that you have to be aware of inside. See, simple. Spark is also basically a cluster. So just imagine you have slave 1, slave 2, slave 3. Again, I have a file which gets divided of 3 blocks. Code comes to all the systems, same thing. There is nothing different here till now. Okay. That is absolutely same compared to the MapReduce approach. Okay. Now what happens when the code comes to the respective nodes? Obviously, the code will be applied on top of the block. It generates an intermediate output. Now this is also same as MapReduce, right? But where comes a difference? This intermediate output, I'm not going to keep it inside the hard disk. Rather, I'm going to keep inside the RAM of the system. Please observe carefully. I'm going to keep this intermediate output under the RAM of the respective slaves. Now, all of you know the difference between something that's been stored inside the hard disk and something that's stored inside the RAM, right? So now when you are storing something inside your RAM, obviously I'm going to read it much faster and much efficient, right? Now, what your Spark is suggesting, see, what was a major drawback of MapReduce? Each and everything I'm going to store inside the hard disk. Now, over a point of time, my hard disk space will also be exhausted. And also, I have to do numerous disk reads, which slows down the performance. Instead of that, why can't we keep the intermediate output in the RAM of the same system, so that when a reduce operation happens, again, let's imagine I'm picking up S2 for reducing. Now, when S2 starts its reducing operation, it's not going to do any disk read. Rather, it's going to read it from the RAM of every system, which is called memory to memory read. Now, this is a most important feature, or memory to memory read or memory to memory write. It can be in both ways, right? Now, what is the important feature of this memory to memory read? Both these machines are connected to each other. Of course, all the nodes are connected to each other inside any cluster. Now, the data transfer will happen between the RAM to RAM. What is the biggest advantage of this? It can be done really faster. Compared to the disk read, your RAM read operation or your memory read operation is going to be really faster, which will not slow down the performance unlike in your MapReduce. Got it? So all of these intermediate outputs are going to be stored inside the RAM. From there, it will be read and it will be used for the reduction operation of your node S2. Now tell me, till this it's clear. See, there are too many things that's going to be involved. So I would like to split them one by one. I don't want to push it out everything completely at one shot. It will be difficult. So till this process, is it clear? That there is going to be again fault tolerance here. There is again going to be something called lineage here, which we will learn. But since just now we completed MR and we understood about the disadvantage of it, quickly understand how we are going to overcome it with the help of Spark's memory to memory read operations.
Can you please repeat after storing this intermediate output in RAM after that?
So you're storing the intermediate output inside the RAM. So then the map phase is basically completed, right? Which is individually processing the blocks is completed. What's the next step? Which is, of course, reduce. Right? See, the same approach of MR. The only difference here is instead of writing them into the hard disk, I'm writing them into the RAM. So what's the next process? Reduce operation needs to happen. So again, master will pick up any one of the node to do the reduce operation. Let's imagine it's going to be S2. It can be S1, S3, or whatever we have. I'm just assuming it to be S2. So now S2 knows, okay, S1 and S3 has also finished generating their intermediate output. Let's go ahead and do a memory to memory read. So it will read from S1's RAM, the intermediate output, and S3's RAM, the intermediate output, do the consolidation, generate the final output.
Here are the operations will be n-1, right? Number of
No, here
blocks.
there is no need to operations itself, because when we go into disk read is where it consumes time, and that's where we are worried about the number of disk IOs I'm going to read. Here it's not even coming under an IO, it's basically a memory to memory transfer. So even if it is going to be n or even more than n, it's going to happen really faster. So we don't have to worry about the IO operations happening here.
Okay, but my question was regarding like S1 is also using its own RAM, right? It's storing the intermediate output in its own RAM. The S3 is also storing the intermediate output in its own RAM. So although we are not concerned about the memory bandwidth issue that was with the MapReduce or the Hadoop, but in the backend it works in the same principle, right? In the n-1.
Yes. But then the reason why I'm saying you don't have to even consider that is it's not
Okay.
going to consume any time for that.
Okay. Secondly, don't we going to have any memory issue with the RAM also? Since
Perfect.
RAM storage is lesser than the hard disk storage.
Yes, that's a very valid point, and it's a very simple thing to. It's obviously a very simple question, because in your hard disk, of course, I will be having more memory. I can store how much ever I want, but then RAM is of limited. I know it is faster, but at the same time, it is limited. We'll come to that. So that's what I'm saying. I'm not dealing everything right now. There is fault tolerance that we are going to see. There is lineage that we need to see. But before seeing all of this, just understand how, as of now, Spark is handling the disk challenges. We will come to that. I know RAM is of lesser memory, how we are going to keep all of this intermediate output there when the RAM gets exhausted beyond a point. Also, RAM is a temporary memory. What happens if that node goes down? Right, Pranjal? All these questions are there, but we'll come to that one by one. So as of now, it's clear for you? Okay. How S2 knows S1 and S3 intermediate output is generated? Obviously, right, Ram Srinivas? Every third second, your your slave node has to send a heartbeat, and in the heartbeat, it will inform, okay, I have generated OP1 as well. See, every single action happening inside the slave node has to be intimated to the master. Then only the master can understand what is actually happening in the overall cluster. Right? So the master knows, okay, S1 has done the job, S3 has also done the job, and S2 has also finished the job. Then it will understand, okay, S2 is having good memory space to do the job of consolidation. It will go ahead and trigger the information to S2. Hey, come on, S2, you have enough memory. So what you want me to do is go ahead and read OP1 from S1, OP3 from S3, merge all of them, give the output. It's a big signal. What you will be having inside the heartbeat signal? There is a compressed data. We seen that yesterday. No, inside your heartbeat signal, there are informations which are getting compressed, so that the master can understand what's happening within him. Okay. And I saw somebody raise their hand. Is that question clear now?
No, I did, but he said I wanted to ask question as regard the temporal and RAM being temporal storage. What happened? So he said you answered later. That's why I thought.
Okay, no worries, no worries. Because see, that's what. So there are too many things that we need to learn here. So let's not dump everything at one shot. Let's learn piece by piece, so things will be much more easy and clear for you guys. Fine. So now we have understood at a very high level how your Spark is satisfying or overcoming this issue of numerous disk reads, right? But let's understand more about Spark. So first of all, what is Spark, right? Spark is basically a simple cluster, right? Just I'll stop this. I'll show you guys the official link of Spark.
Sylvia, just one more thing. Can you grant us access to these whiteboards? I'm getting a message that I need to request access for these whiteboards.
I have already given it before even sharing.
Actually, as soon as you stop sharing, so there is the link pops up in the chat. So when I'm trying to access it, it is saying that request access.
Okay. You like your permission. It's not showing to me either. There is a picture it's coming above. That's also not visible, is it? I'll do one thing. Probably when I end the session, it will be asking me to, because even I'm not able to give access. It is saying admin can only give the access, and admin is from the team of Tutort. So
Yeah.
even for me, it is mentioning request access. So probably I'll do one thing. I'll ask the team to give you access, because even I can't give the access right now.
Okay. Access,
Okay.
required for both the whiteboards.
You just do one thing. You just click on the request access so that
Mhm.
your
Yeah,
invitation will go.
I already did
Okay,
that.
fine. No worries. I'll ask those guys to share. Fine. So now let's see on what is Spark first of all. So now we know a little bit about Spark. Spark is much faster compared to the MapReduce approach, but what is more about Spark? So this is the official website of Spark, spark.apache.org. as I said yesterday, Spark is also coming from the same organization. It is an open source again, right? Now, Spark is a multi-language engine for executing engineering tasks, data science tasks, and even machine learning tasks. Most importantly, can either be deployed on a cluster or on a single node. Of course, in your industry scenario, nobody is going to use a single node. We will be using a cluster. But understand that it can also be deployed on a single node. Now, what do we mean by a multi-language engine here is it can use Python, right? It can use R, it can use SQL, and it can use Scala also. Now, Scala is the home language. Scala is a language on which the entire framework is built. But the same can be deployed, or you can write all of your codes in any of these languages. So if you're someone who is having a strong background on Python, you want to learn Spark, then there is a separate module for that, which is called PySpark, Python and Spark together, which is called PySpark. So once you install this, you can go ahead and start working on Spark related operations. Okay. So now let's go a little deeper. So simple, fast, scalable, and unified. Now see the key features. The very first feature itself overcomes the drawback of your MR, which is it can process streaming data. It can also do SQL-based analytics. So if you have already an RDBMS data, which is really huge, your RDBMS is struggling to process that. Now you are planning to move it into any cloud or into any distributed file system, then better move it into Spark. You can make the best use of that. You can still use your same SQL codes, but only thing is the storage is not inside your RDBMS. Rather, it is going to be inside your Spark cluster. Right? And along with this, an added advantage is how much time it takes inside your RDBMS. That's going to be much, much faster here in your Spark. And you can do it all of your data science based or machine learning based queries as well here. So the language that it support, like as I already said, Python, SQL, Scala. Yeah, you have Java also. And for your course, I believe you guys have a module already on Python and SQL.
Yes.
Yeah.
Right. So even in this course also, we are going to cover both of this, handling Spark using Python as well as using SQL. So this is what we are going to cover here. And yes, some of the organizations which are using this under the hood, what is basically Spark. So all of this, whenever you guys find time, please go ahead and read this website. I'm not going to read all of them right now, but I would suggest you to go ahead and have a read on this page. So in short, what is this, right? So just observe this. So Spark is basically nothing but a cluster at the end of the day. Now it can be deployed on a single node, but then nobody is using it in an industry-based scenario. So again, we will also talk about in terms of cluster, right? Now, what you need to know in order to work or in order to deploy in a Spark. Now, when we go to Hadoop, please observe this carefully. Many think Hadoop versus Spark. Ideally, that's not the case. If you go to I'll share my LinkedIn article page also. I have written an article also about how to compare the differences. So it's not always Hadoop versus Spark. Rather, inside Hadoop, you have two components. Can you guys tell me what are they? Yeah, what are the
STML and
MapReduce and EDFS.
Exactly, right? Now we know this is purely for storage. This is purely for processing. Meaning, you have the entire setup ready when you start deploying something inside a Hadoop cluster. You don't have to worry about the storage. You don't have to worry about the processing approach. You have the data residing under the HDFS. Read from HDFS, process it with the help of MR, generate the output, store the final output again inside your HDFS. So it's like a full package. But when it comes to Spark, Spark was mainly invented in order to overcome the biggest drawback of MapReduce, which was the two biggest drawbacks that we discussed, right? Numerous HD disk operations and stream process. Now, both of them, in order to address both of these issues, is where Spark came in picture. So ideally, Spark is not a full package which includes storage and processing. Rather, it is purely a computation engine only, a processing framework only. And hence, when someone is saying is Hadoop best or Spark best, of course, Spark is going to be of much more efficient, but Spark is not a complete package, meaning it is only a computation engine. Then there will be a question on from where it will read. When I say it can only process, where the storage is going to be, right? Now, please understand, Spark does not have a file system for storage. And because of this reason, I will not compare Hadoop and Spark directly. Because that's not reasonable to compare, because Hadoop is an entire package. You have a storage, you have a processing engine, wherein Spark is purely a processing engine. So now we are saying it does not have a file system on its own. Then the immediate question is from where it will read, right? If you're saying it's not having some default file storage system, from where it will read? Spark can read from multiple third-party file systems. It can be easily integrated with Hadoop, so it can read from HDFS. It can easily be integrated from AWS. It can read it from S3 buckets. It can get easily integrated with Azure, GCP, or any other clusters which is having a file system. So there is something called Databricks also. Maybe you guys would have heard about it. If not, just imagine that's also a platform, a cloud platform like we have AWS and Azure. So it can read from any of these third-party file system, read the data from there, and process it with the help of the Spark's computation engine. So that's why a direct comparison is not ideal, because Hadoop is involving storage and process, wherein Spark is just purely a processing engine. Maybe it is ideal to compare like this: Hadoop's MR versus Spark. That would be the ideal way to compare. The MapReduce approach of Hadoop and the Spark's computation approach. That's how you have to compare, and not an entire Hadoop and Spark. We cannot compare it anymore. Fine. So imagine this is your Spark cluster, right? Now, I'm saying Spark is going to read from multiple third-party file system, which internally tells you Spark can be easily configurable with all of these file systems. Now, since you guys have learned in this module, you have some idea on HDFS, I'm going to read the data of my Spark from HDFS, just for the explanation's sake. I'm going to consider this is my Spark cluster, which is also a Hadoop cluster, by the way, and hence it has the HDFS layer here. This is my slave node 1. It has the HDFS layer here also, S2, S3. So the storage is going to be read from HDFS, but I'm going to bypass the MapReduce approach and I'm going to use a Spark's computation approach for processing. Okay, so this is my master. These are my slaves. So as usual, the same story. File F is there, gets divided into 3. Remember, this is Hadoop's cluster. So where these blocks are stored? HDFS. A, B, C. Now I'm going to run my Spark code. And I'm going to write inside my Spark code to read from the HDFS blocks. Right. So it will be picking up the data from these HDFS blocks and it will process with the help of the Sparks frame. So this is the basics that you need to know about Spark. So Spark is again a computation engine which can be deployed on a cluster. Now Spark can read from any of these third-party file systems, any of the third-party clusters. So that's why when we say the projects are getting migrated from Hadoop to Spark, the entire data of your HDFS will still remain in HDFS, but the MapReduce code is getting shifted into the Spark's way of processing. Okay. Yeah, Ify, please go ahead.
Can you please explain this Databricks again?
Databricks, we are going to work on the lab of Databricks. So Databricks is basically, it's an organization which was built basically from the people who invented Spark. So there was a team in Apache who came up with the idea of Spark, and those people have moved out and they started this organization called Databricks. Now, what these guys basically do, they give a complete support for Spark related operations, and they have also come up with their own cluster where the cluster is pre-built with all your Spark's initialization. You can just hire systems from their cloud and you can start your Spark processing there. You can even write machine learning codes also there.
So is it like AWS?
Exactly. It's basically like another cloud service provider, but specifically meant only for Spark processing.
Okay. So my question, I don't know if the question is necessary now. So you have, you say the HDFS is for batch. But
Hadoop is meant for batch processing,
yeah,
not specifically HDFS.
Yeah, batch. Then you are using it for Spark, and you say Spark can be for batch and streaming. One of the features when you were introducing it from the side. So how would the process of Spark handle streaming here if it's only using HDFS?
That's not the case. See, if it is only going to be using HDFS, then what we basically need to do, we have another component which will be streaming of the data and putting it inside the, see, HDFS is just a storage layer. It's not a processing layer at all. So what will happen in such scenario? There are other tools, say Apache Flume. Now, what this Flume is going to do, this is going to only read the streaming data. So what will happen, that streaming data comes and gets stored inside HDFS. From HDFS, your Spark will read it and process it through the computation approach, through its own computation approach. So there will be an intermediate service which will be needed to just stream in the data to HDFS.
All right. Okay. Thank
you. Okay.
Hi, I had a question. Yeah, so the Spark in itself, can we say that it can't have any independent usage of its own? Rather, it's like a something that can be used in other structures like Hadoop.
I wouldn't completely take it because see, at the end, when you want to process it, you need a file. Right. The only biggest challenge with Spark is it cannot read it directly from its own file system because it does not have any as such. So if you mean it's not independent because it has to always rely on a third-party file system, if your question is based on that way, yes, true. Because it needs to read always from a third-party file system. It's only a processing engine which works at its best, but it needs to be dependent on any of the source file system to read data from there. But it could be DBFS, which is Databricks file system, HDFS, which is your Hadoop file system, or AWS, or any of these files.
What about the storage output? I mean,
again, it stores from in whatever file system it reads, on the same file system, it stores back the data.
Got it. So I am kind of nearly right.
Yeah, that's what I'm saying. See, but then why I'm not saying it is always dependent on something is we can say it in the reverse way. So AWS or files inside HDFS or files inside AWS can be processed really better if they are dependent on Spark. Got it. If they can prove their efficiency if we process the data residing inside HDFS with the help of your Spark.
Yeah, I mean
Because,
Spark is a refined feature, we can say, right?
because it proves to be 10x to 100x efficiency compared to Hadoop. I'm not saying directly 100x. Many times people do mistake that Spark is 100x efficiency compared to Hadoop. Not in all situations. 10x to 100x efficiency you can find between Hadoop and Spark. So maybe the reverse way we can see these guys have to be dependent on Spark in order to prove their efficiency. Yeah.
Got it. Yeah.
Fine. So now we know about a little bit about Spark. It is a cluster, it can be deployed on a cluster. It does not have a file system on its own. It's in and out and processing engine. So it has to read from a file system, process it, stores back again on the same file system. Now, the overall Spark has been divided into 4 components. So one is called core, another is called SQL, streaming, and machine learning libraries. There is one more called graph also, but that's not there right now within Python, so I'm not going to talk about it right now. So there are 4 core components right now inside your Spark, right? I'm not going to provide you the lab in terms of Scala. It's completely going to be through Python and SQL. Okay. And in this course of yours, we will be focusing on core and SQL part of your Spark. Okay, what are these 4 components under Spark? Core is basically you can process all kind of data. It could be a structured data, it could be an unstructured data, it could be a semi-structured data also. Basically, read any data from the file system, process it here through your Spark engine, and then sends back the output. The second component of SQL is purely, as the name itself clearly says, no? It's purely for handling one and only structured data. But Spark SQL has lot of intermediate services which can read from quite a different file formats. So have you guys heard about or use these file format? Sparkware, JSON, Avro. Of course, CSVs you guys would be knowing. And in JSON itself, embedded JSON is there. Do you guys have a module on MongoDB or any one of the NoSQL databases?
No.
If
Not it.
okay. But is it a part of your course?
Yes, I guess it is part of the course.
Yes.
Okay, great. So you might, in that MongoDB course, you will be learning about something called embedded JSON. I'm sure right now you will be having some idea on JSON, which is basically nothing but a dictionary kind of file format, key and value. Now, embedded JSON is a little advanced of it. Basically, it's embedded documents present inside. Now, the biggest advantage of Spark SQL is it supports all of these complex file format, and in which some of these file formats, ORC is also another one. Now, these ORC or Parquet file format are really efficient, or I can say in another way, they are used a lot in big data platforms. And processing those kind of files through Spark SQL becomes really simple and easy, wherein core cannot process these files. Spark core cannot handle ORC or Parquet-based files, wherein Spark SQL files can easily handle ORC and Parquet. If we convert these complex format into basic, then of course Spark core can handle it, but it does not have direct drive to read it and process. Streaming is basically for handling real-time data. So you guys would have heard about Kafka. So suppose I'm having data coming up from Kafka or any other third-party real-time systems. I want to parallelly read it and process that. Then you can make use of Spark streaming, which is of course not possible in your Hadoop, right? Machine learning libraries. Now these are basically nothing but compiled bunch of Scala libraries. So for example, like your linear regression codes, your logistic regression, all of your clustering based algorithms, all of them can be deployed using the Spark's machine learning library. Just like how you have your scikit-learn or all of the other libraries that you're using in Python, when it comes to Spark, if your data is residing in a cluster, you can read it and apply your machine learning codes with the help of this component. Okay. So these are the 4 components that we are going to see. And these are the 4 components of your Spark, in which for you guys, it's going to be on core and SQL. I have not done the SQL, so can I be able to get things? See, we are going to learn it in 2 ways. One is through API, for which you don't have to know about anything about SQL. And there is another option wherein you can write an SQL. So if you haven't done the SQL part so far, you can stick with the API based of operations here. And once you finished your SQL module, you can try out the other approach also. So this is to Priya. Fine. So before we go ahead further and understand on how the RAM is going to be used efficiently over here, we will set up the lab first.
I'm sorry, I have tuned in late. May I just have a short description of what has been done so far?
It's more than 1.5 hours. It's 10:30 now. We started at around 9. So I would suggest you
What was the
please
topic?
go ahead.
What was the topic?
It's in Spark. Spark, Apache Spark.
Okay.
Yeah. Right. So let's see how the lab is going to be set up. Guys, please do stay on mute. Let's see how we are going to set up the lab for our Apache Spark. So there are 2 ways in which we can do it. So there are multiple ways, of course, in which we can do, but then we are going to see it on deploying it in a cluster, right? So you can do it on a standalone system also. So you can go to the Apache Spark's website, and from there you can download the bin file. You can install it on a standalone system and you can process. That's one way, but that's in a complete standalone system. If you want to deploy it in a cluster, right? Now, there are multiple options. You can go to a Databricks website. You can hire a community edition. They will offer you so-and-so configuration of systems for free. But if you want to get a licensed also, you will be charged based upon how much configuration you need. That is one way. And another simple and quite common approach that many learners follow is through Google Colab, right? Or you can hire systems from Cloudera, which have Apache Spark pre-built on it. You can download that and you can have it as a pseudo cluster and you can start working on it. Now, among all of these options available, I'll give you 2 options, right? Now, those 2 are the simpler one, but yet the effective one, and they are also in the cluster mode also. It's not in a standalone mode. So the first approach is Databricks website. So go to databricks.com.
Your screen is not visible.
I'm just going to share it. I haven't shared it yet. Okay, so this is the Databricks website. So databricks.com. So what is Databricks? As I said to IFE's question, it is basically an organization created by a team of people who were the original owners of the entire framework of Spark. So they moved out of Apache. They created their own organization, which is Databricks. Now, what is their biggest strength? They provide you a complete cloud support for all of your Spark related operations. You can even deploy machine learning codes over there, or you can even deploy data engineering projects over there. Okay, so first head into this databricks.com. If you guys want, you can parallelly do it along with me also. Not a worry. It's a simple step. Okay. Now, when you head into this, on the top right, can you find something called Try Databricks? Click over here. Now it gives you two options. One is a professional use, and another one is for a community edition. Now we are going to use for a community edition right now, because for professional use, it will start up for free, and then over a period, you have to start pay for it. Wherein a community edition is also quite simpler to that, but this is absolutely free, right? And whatever things that we are going to learn, your Spark Core and Spark SQL operations can be completely learned end to end. It can be learned with the community edition itself. So click on Get Community Edition. Okay. Now here it will ask you sign up for a community edition. Okay. Now you can provide any of your email, not necessarily work email. You can continue with any of your email ID and just simply click with continue with email. Now remember, when you provide this email, please do remember the credentials of your email, because every time when you log in, it will send up a OTP kind of stuff, which you have to paste it out here in order to log in. Okay. Yeah, Shraddha, tell me.
I'm not getting that screen. I'm just directly getting a screen to create a Databricks account. Should I proceed with that?
So
It's
this
not.
is a page you have to be in.
Yes,
From
yes,
here, click on Try Databricks.
yes. I'm not
Two
getting.
options.
I'm also
No.
getting this. I'm getting to sign up.
Yeah.
You
Same
can
with
do a
me.
sign up also, or you can direct. This is screen you're getting directly, right?
No.
Oh,
I'm getting a screen to create an account.
So we are
Create your
not getting
data.
this screen. So we are getting to create an account and it's access from some
The,
corporate email ID.
that's what. So basically, that's what you will get after this also. So anyway, if you are reaching it, see, basically the
Hello.
thing is we are going to sign up. That's it. So go ahead, provide the details, provide your mail ID, and generate your user account.
No, when I try to log in, it's asking for the corporate email ID. So do you have to give the official like?
Who is this? This is
In,
Deepak. Deepak,
in,
can you share your
individual ID will
screen?
also work.
Yeah. That's what I said. Not necessarily it has to be in professional ID, but I would want any of you to share your screen. So probably I can guide it from there.
Okay.
Who is actually having that screen? Can you raise your hand? I'll give you access.
I have the screen, but it's saying that disabled for sharing. Can you tell me?
Okay. Okay, this is Deepak, right?
Yeah.
I'll make you host so you can, or else wait. Yeah, now you can share Deepak.
Can you see my screen?
Yeah, this is a screen we will be getting up. So people who are in this particular screen, see phone number you don't have to share, please take it out. Yeah, the optional fields you don't have to provide, and provide the first name, last name, mail ID. Company title, you can just give some random ones, not necessarily your specific ones, just give ABC, whatever, right? Choose all the option, India, yeah. That's an optional one. Whatever fields are optional, please don't provide. Only thing you have to be sure is the mail ID should be proper. And it can be your personal ID also, not necessarily your official ID. Hold on to the screen, Deepak. So here you will be getting two options. One is a professional use and the personal use. Now, it is quite similar to what you have seen on my screen. The only thing is the UI is different here. So professional use, please understand what does it mean. In professional use, they are giving you three options, which is AWS, Azure, or GCP. Meaning, Spark cannot read it from its own file system because it does not have one. It needs to read from a third-party file system. Now, in order to read it from any such file system, what Databricks is offering you, if you have an account on AWS or Azure or GCP and you have your files been uploaded into any of these three, then better connect your Databricks with that account so you can read it from there, process them using Spark directly from Databricks here. But in our course, we are not going to use any of this because I believe you don't have any module on any of these three, so you will not be having an account or you will not be having an idea on how to use this. So come to the second half, which is personal use. So this is where the one that I earlier said is a community edition, meaning Databricks itself is going to give you a file system, and it is called as DBFS, Databricks File System. So instead of AWS or Azure, we are going to upload some files inside DBFS, and from DBFS, we will read it and process it through Spark. So click on the Get Start with Community Edition. Okay, yeah, it will ask for a simple puzzle. Yeah, just direct it accordingly. Use the arrow to, yeah.
The signatures of your hand.
One more time, right side. No. Right, yes. Submit, no, submit. Okay, so now it creates an account for you. So what you have to you go to your mail and there will be an email that comes to you from Databricks. You can just stop sharing and you can go to your mailbox, click on the link, and then you can share.
Okay.
Hope others are following. Once you click on the link, again share the
I'm
screen.
getting a screen with import and transform data. Did you get anything different? I'm not able to see
No,
your screen.
just hold on. Let's finish with Deepak and then I'll come back to you
Okay,
guys.
sorry.
I'm sharing again.
You're sharing the screen? Yeah, share it again.
No, it's okay. I'm sharing again, but
It's not letting you share again.
yeah, it's sharing. Okay. I got this mail from Databricks, but
There. Click on the link to activate it. That's it. Click on that link. You have given your official ID, is it?
no, this is my personal ID.
Okay.
Yeah.
Can't be found also.
It will login.html.
Yeah, but it's not rewriting for me. I don't know.
Just copy till login.html. HTTPS community cloud, not the entire one, the first link. Uh,
I think
yeah, yeah.
it's not, instead of being in the next line, it's there on the same line.
No, Deepak,
No,
get started by
first up.
visiting after that till HTML. The first link before the arrow.
Okay. Okay.
Yeah, just that part.
Just copy na.
Yeah, it will share you an OTP. Go to the mail again. So all of you guys also should do the same as how Deepak is doing right now for the login part.
Okay.
Yeah. So this is a home screen. So when you get this, we understood, okay, we have successfully created an account inside your Databricks. So this is a community edition. So there are certain features which are probably not visible or not enabled out for you. Okay. So if all of you have reached this particular screen, then that's it. We are good in setting up a account. Okay, do you guys want me to wait for a few minutes or shall we continue? Okay, fine. Deepak, here on the top right, you could see a D inside a circle, no? Top right. Yeah, click on that. So this is your profile. You have your settings. If you want, you can delete an account, log out, and all this stuff. So please head into settings. Okay. Here you will be getting to know the details. So go into advanced option on the settings. Scroll down. Yeah. So now please observe, if you guys are doing also, please stop that. Please observe this. This is one settings change that you have to do in all of your systems. So what he did is on the top right under his profile, he went to settings, and inside the settings, he moved on to the advanced option on the left side. And when he scrolled down, you could find there is an other section, right? The first one is the third party framing prevention that is by default on. The second option is DBFS file browser, which is disabled by default right now. We need to toggle it on. Yeah. Now, what is this DBFS file browser? Remember, again, Spark does not have a file system on its own. So it needs some file system from where we can read and write. And if you're in a Premier Edition, then we can read it from AWS or GCP, whatever we have chosen. But since we are in the Community Edition right now DBFS offers you a free file system, which is called Databricks file system. That is what DBFS means. Now, by default, you will not be having an access. So what we are
Sylvia,
doing
I'm
is
sorry, I just missed where I can see settings.
on the top right under your profile.
Yeah.
Yes. Yeah, please show.
Hovering the top right pane, and then the D is there. So click on its name.
I cannot see it. I'm sorry. Just a second. Yeah.
Okay. Are you in the home page, like in the after login?
I saw it now. Yeah. Thank you.
Okay. Fine. So you guys have to toggle on the DBFS file browser. And once you toggle on, just do a refresh on the web page. Just click the refresh icon.
So when you get to the setting, I missed the step. What else?
On the top right, your profile name would be there. The first letter of your profile name, D here in case of Deepak. So click on that. You will be finding the settings.
Yeah, that's what I'm saying. After clicking the settings, what next? To get
On
to
the
the
left side, you have advanced, identity and access, security, compute, advanced is there. Click on advanced. Deepak, can you keep your cursor over there on the advanced on left side? Yeah. So this is a place. And then just scroll down, go to other. In the other section, this is a second option.
EBFS5 browser.
Yes. Okay. Great. Thanks, Deepak. Yeah, you can stop sharing. Give me a sec. I'll log in my account, and going forward, I can show it from my screen.
Sylvia, I have a question. You mentioned we can also use Google Colab as an alternate, right? So functionality wise, we'll get the same capabilities between Databricks and this one, right? I mean, I know Databricks has the pipeline option and data ingestion, all this, but at least from this class perspective, we can achieve the same in the Colab also, right?
Exactly. In all the three, yeah, whatever I'm going to show you in the community, you can do the same in all the three. Not only in GCP, in all the three. The only place that might differ is you need to generate a token. You need to provide the token in order to access a file from AWS or GCP. Wherein here, we have a pre-built file system. We will directly read from the file system. That is the only difference. Processing wise, it is exactly same, irrespective of which mode you are using.
Okay, then. Thank you.
Okay. Fine. So now you guys would have reached this place. I believe all of you have reached this. On the left side, you will find new workspace, all those blah blah stuffs. So what I want you guys to first do, head into catalog. There are two options, database tables and DBFS. When you click on DBFS, you will be able to find, you'll not be find all the stuff that you're seeing on my screen, at least the limited bunch of folder options you will find. Now remember, this DBFS is not visible if you haven't toggled on the settings section. So that is why we enabled the DBFS file browser. If you haven't enabled it over there, you will not be able to locate it here directly. My screen is split. Just give a sec. Okay, so go to catalog, go to DBFS. You should be able to view some or the other folders here.
We have only one folder.
That's fine. I think you will be having only file store or user or something.
Yeah, only file store, and inside file store there are tables.
That's fine. So these are something that I'm having in my account. Slowly, you guys will also use all this. Fine. Now, the next thing that you need to know is compute. Now, as I said, Databricks is going to offer you a cluster support. Now, it's a community edition, right? So the size of your cluster is not as big as it is, as we generally use in your industry-based scenario. But
sorry,
within,
but I'm not able to see that another folder beside data. Though I have enabled my this one.
You have to refresh your page.
Refresh?
Refresh your page.
Okay.
Okay, refresh your page will be. Okay, fine. Now coming to the compute that Databricks is offering for a community edition. Now please understand this is a community edition, so we can't expect big here. So what these guys are offering for free would be 15 GB of RAM with 2 core processor. This is the configuration that they provide, just a 2 core. But if you go ahead with any of those cloud service providers, like we have seen one among the 3, and if you have an account, you have hired systems, but you will have a better reach. But since this is completely free, this is a max support that they can offer, right? So you're open to choose either the community edition or choose any of those 3 cloud service providers. The choice is absolutely yours. Now,
sorry to interrupt you. Sorry about that.
Yeah, tell.
So when I refresh my system, it's still showing setting, and I don't like the way it's clustering my page, because I click on the new and the catalog, and I'm still having both the settings and the new. I don't know why.
So which one you are seeing? I'm not getting it. When you click on new,
after changing the order, turning on the DBS file.
Catalog,
So
you're
what
able
I'm
to
saying,
view?
the setting page is still on my screen. I want it out.
Okay, just click on back. It will go ahead. I understood. So what you're saying is, when you're going into this page and you are here and you refresh, you're still on the page, just click on back. You will reach to wherever you are.
Okay.
Fine. Coming down to compute again. Okay. So please observe this. We need to create a compute. So go to the compute on the left side, click on create compute. Okay. So here we are going to create a cluster. As I said, it is of 15G RAM, and it is going to be of a 2-core processor. This is a default that it can offer for a community edition. You cannot increase or decrease it. Okay. Now you can change the name of your cluster. So I'm giving here as Tutort cluster or something. Okay. Can provide any name. Okay. Just give a name, and there will be a version, which is again by default. Spark's version is 3 and Scala's version is 2.12. Now, if you wonder why Scala is here, because Scala is a language on which Spark is built, right? And what does the instance say? Guys, please do stay on mute if there are no questions. I'll come back to you, I see. I have seen your hand being raised. I'll come back to you. So in the instance, it's mentioned it is a free 15G. It's a community edition user. So your compute will automatically terminate after an idle period of 1 or 2 hours. So please be very clear here. Many students get confused. What they are saying is they give you a cluster for free, which is of 15G. Now, when you open the Databricks edition and you connect to your cluster, you start working in, you kept that spin idle for an hour, the cluster get terminated. But all of your work is saved under your account on the same Databricks section. Don't think your work is also lost. Your files inside your DBFS is also lost. No, only the compute engine is lost. Only the RAM that we are needing for our computing purposes is lost. All your work, all your file is still saved. So what you have to do after an idle period of an hour, you can again open your worksheet or your notebook. You can connect with the cluster again. So what your Databricks at the back will do, it will connect with any of the 2 cores which are available under their server, and it will offer it to you. So you can make use of that compute power and do it. Don't think all your work is lost. Your work is nowhere lost. Your work will be available under the workspace section, which I'll show you. I'll come to the workspace. But before that, we need to know about the compute. So click on create compute, provide a name here. Okay, any name you can offer. Provide a name. You don't have to make any changes here. Okay, just scroll down. Just simply click on create compute. That's it. Okay. Can you see the circle is rotating? It will take few seconds and then it will create that cluster for you. It's not a big cluster again, I'm repeating. It is just a 15G with 2 cores. That's it. Right? Now, once the cluster is created, it will come up saying the cluster has been created and you can go ahead and start your cluster at any point of time. Once you start your cluster, we can make use of that for our process. Okay. Yeah, let it create. Meantime, yeah, I feel you can ask your question.
So sorry, I need to take you back. When I click, when you go to catalog, you see folders.
Catalog, yes.
I have only one, which is just
That's fine. That's fine. That's you are just creating an account now, so there will be only one folder.
So is there anything we need to do here?
No, nothing as of now. I'll tell you there are few things you guys have to do, but I'll tell you a little while.
So we go to compute and create. I can see your Spark has a lot of
No,
activities.
I think
Another
I
thing
told this already. So it is, I mean, for me, you can find a lot because I have created all of this. Even when I created, there was only one folder, which is files.
Okay. The compute, back to the compute. The computer.
Now it's clear, no confusions, right?
Yeah, this is clear. Then compute.
Compute, it's you have to go and click on create compute, just provide a name, click on compute. It will get started out.
So the
can
only
you
thing
see?
we need to change there is just the only thing you need to modify is name.
Yes,
not
or else you can go with the default name also, not a worry.
Yeah, there's
your
nothing else to do there. Nothing. All right.
Yeah. And once it gets started, you will find this green screens, a green circle. Can you guys see it's cluster running? Okay, so my cluster has started running. Fine.
So
Yes,
after
Pari.
ideal period, it will be paused or something, right? And we need to unpause
Restart
it.
it.
Complete.
Yes.
Okay. Okay.
Yeah. Yeah. Yes, Bharati.
I can see that active is 2 cores. What is it 2 core? Is it data nodes or what exactly 2 cores?
No, the 2 cores will be taken according to the architecture. See, overall, there are 2 cores. Now, in your Spark, there is nothing like name node, there is nothing like data node. We'll come to the architecture. So, we do have something called executors. So, now these 2 cores is going to behave as executors inside. Okay, as of now, just understand 2 core. When we come to the architecture, you will know how these 2 cores are going to be used. Fine, guys. So now the cluster is up and running. You can see the stop icon being here, which means it is already running. Okay. Now head into your new. Okay. In the new
It's
section.
still creating cluster for me.
That's okay. It will take its time.
Okay.
Not a worry. Okay. Go to new and you can find a lot of stuffs over here. So as of now, we are going to do a notebook. So head into notebook. So now this is quite similar to the Jupyter notebook, if in case you guys have used that. Have you guys used Jupyter notebook?
Yes.
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 Don't you think it is similar to that?
Yeah, it's similar.
Yeah, so that's what we are going to do. So this is going to be our workplace. And this is where we are, I mean, if at all we are choosing Databricks as our platform, this is a place where we are going to run our code. So I'm just simply writing a code here. Now there are multiple options on the programming language you have chosen. So on the top, if you could see, if you scroll it down, there are 4 options. Now I'm going to stick to the default one on Python because that's what we are going to use here. So this is by default, you don't have to do anything. Now just type any code that you have, click on run. Okay. Now once you click on that run, you could also find the name of your cluster that you have, name of the compute. See, the compute is basically the cluster here. So the name of the compute you could find here with a green dot. This means you are attached to your compute. And whatever code we are going to write over here will get executed. Okay.
I'm
So
getting a window saying attach and run. Should I click it on?
Then it means you haven't started it directly on the way that I said. Now, if you are getting it like that, create, attach, and run, go ahead and click on create, attach, and run. See, that is how you will do when you restart it. Suppose you have an 1 hour of idle time, your cluster goes into the shutdown mode. Now you want to run the code again. When you click on run, it will ask you, I need to create a fresh cluster for you, a fresh compute for you. You want to create, attach, and run. Simply click on create, attach, and run.
Okay.
It's only attach and run, no? Not create.
See, if it will be create, attach, and run for the very first time. Simple thing.
No, it is
Attach and
attach
run
and
for the
run.
second.
Yeah,
Very
I got
sure.
it now. Yes.
See, it's a simple thing. In the first time, it will be create, attach, and run. Starting from the second time, it is just attach and run. That's it.
Okay.
Got it? So
Yeah.
clear, everyone. Any issue? Just do a simple testing like this, just to check whether you are good.
I wanted to ask question. Do I have to get the cluster up and running before executing this notebook?
Not necessarily, because when you're not using it, automatically it goes to the idle mode.
Because it has not been created for me.
That's what you don't have to shut it down, because it's not going to be chargeable or anything also. And it is just a cluster which is for free to you. It gets connected. If you're not using it, it goes to the idle mode automatically. It gets terminated automatically.
No, what I'm saying, because, okay, so it's off now. Thank you. It's been created.
Oh, it was still running out for you?
Yes, yes.
It will take
Just got
time
created now. Okay.
depending upon your internet speed and stuffs. The
Okay.
time varies. Fine, guys. So any other questions? We have taken a good amount of time here, so I hope things are completely clear on this lab. Now there is one more way also,
Yes.
which also I'll tell you on how you can uh, uh, use that for your Sparks lab. So have you guys used Spark Collab? Oh, sorry, Google Collab?
Yes. While
It is.
using Python scripts.
Now Google Collab also you can use for your Spark learning. So let me share the screen. So this is my Google Colab sheet. So I can directly type on Google Colab, and then google.research.colab.com will come. And from here, you can go ahead and create a notebook. Now, what is the difference between a Google Colab lab for Spark and a Databricks lab for Spark? Now, please understand that this is a doubt to many of the students out there. Now, Databricks is specifically created for Spark related operations. So straight away, I can create a notebook. I can write my Spark codes directly here. I don't even have to call any libraries. I don't even have to set up any configurations, because this is pre-built for Spark related operations. As its Databricks itself is pre-built for Spark. So that is one of the simplest approach to use or to work with Spark code, because you don't have to dig your head on how I can set the configuration, how I need to import the libraries, what are all the libraries needed for working with Spark. So all those additional headaches are not there for you if you are using the Databricks Community Edition, because they are all pre-installed and ready for you. Wherein when you come to Google Colab, now Google Colab is not specifically for Spark related operations. You can develop Python code, you can develop SQL here. You can also have Spark code. So when you want to write down Spark codes here, we need to take care of importing the libraries. We need to take care of installing PySpark here only. Again, it's not a big deal. It's just 2-3 lines of code, but we need to make sure we are doing it before you can start writing uh, your Spark related codes on Google Colab. That's the only difference. Got it? So is that clear? So often people get confused. What's the difference between these two? This is a simple, straightforward difference. Okay, there is a library called PySpark, which is what we need to do it out here. So you can do that with the help of, now of course this is having Python by default. So I'm not writing anything over here. Just run this. This will install PySpark for you. So pip install PySpark. Py4j is a library name. PySpark is a module name. So when you specify this and run it, your Spark related libraries, all of your Spark related operations will be installed. And then going forward, you can directly start running your Spark queries. This is the one additional thing you have to do if you want to do in Google Colab, wherein here, there is nothing of that sort.
So one question here. So in order to use Python, PySpark is always required, right? That's a minimum dependency.
Reverse, you are saying ulta. In order to use PySpark, you need to have Python.
No, I'm talking about the package, the PySpark package. So Spark to support Python, then the PySpark module has to be installed, right? That's what it is.
No. Can you come again?
I mean, in Spark, it supports multiple languages, right? So one of them is Python. My question is, if the PySpark module is it's not installed, then it won't support Python code, right? That's what it is. So we need to.
Correct. But by default, when you download Spark, it comes with PySpark itself. So there is nothing like you have to separately download Python, then only I can use PySpark. So if you go to Apache Spark website and if you download the bin file, there were earlier days wherein we manually do download Python and then integrate Python with Spark. But nowadays in the bin file itself, your Python package also comes along. So just download the Spark. It comes with PySpark and as well as SQL as well as R. All these three supports.
Okay.
Yeah.
Thank you.
And this, so these are the two modes which we are going to use. Most of the time, I will be showing you in the Databricks website. But then, yeah, I will parallelly show you at times on Google Colab because there is absolutely no difference. Apart from this one single line, there is no difference between both of them. So you can use both. Now, there is one challenge here which also you should be aware of. Now, remember, this is an organization. Databricks is an organization where they give this community edition for free. Now, one of the challenge of Databricks over the years that I'm seeing, because in some of my sessions, I have observed this. What happens is Databricks can go for a downtime. Now, whenever their website goes for a downtime, the first hit will be on the community editions. Now, initially it used to be just for an hour or 2 hours, but then over a point of time, what happens is for 24 hours, they don't resolve it. So there was a downtime for 24 hours. So that is when I realized like, okay, let's also have a parallel lab account so that we'll not always be dependent upon Databricks. It will not happen very frequently, maybe once in a year or max twice in a year, but then if it happens to be our learning time, it becomes difficult, right? So that's the reason I'm giving you two options. But apart from that, Databricks is great because the lab is set up already for you. It's just like a plug-in and play, right? And it is specifically created for Spark also. So better attended. But so hope this is clear. Both the Google Colab and Databricks.
One quick doubt, Sylvia. So
Yeah.
how do we configure Spark when we use when we use it on Colab or on our local machine.
How do you configure? See, you first install this. This is a package which comes with all of your configuration informations, right? Like what are all the nodes that we need? What are all the different algorithms which needs to be called up in different situations? All of them are inside this module, say PySpark. And within PySpark, library called Py4j, Py4j, which is mandate for running all Spark related operations. So the only thing that you have to run in order to configure PySpark here is just this one single line. After this, there is something called Spark context, which we will learn in a while. So when you create that, automatically this whole setup, this whole cluster gets configured as a Spark cluster. Okay, there is no huge configuration or there is no huge initialization steps that we need to write. Just this one single line and two more lines, which I'll show you when you start writing the code.
Okay. So
Okay.
Okay, we can see that during that.
As of now, only this you worry about. And the other two steps we will see, because we need to know a little more before we head into those two steps. What is Spark context? What is a driver? All these informations we need to know. Otherwise, if I explain you guys, you cannot understand. So as of now, you are just installing PySpark. Configuration step is one more, which we will learn in a while. So now what we have seen, two ways. So let's again head back into our in-memory processing. So by default in Google Colab, what is the configuration base? How much memory it supports? How much core and how much RAM it offers? Anybody remember that quickly?
I think the Google document says that 12 GB of RAM for the standard version.
Standard is what we are going to use. So 12G is it?
Yeah.
Okay. And any details about core?
I think, yeah, I'm just referring the Google Doc. Not sure
Okay.
about that. Let me see
So
that.
here it is. Yeah, it is system RAM is 12G and HD is of 107. Okay, great. That would be more than enough for us. Yeah, 12 GB RAM is there, no, which is great.
I think
Okay,
two cores. Two cores it was for the standard edition.
Then it is quite the same, not a difference. Great. I think, but if in case we need extra, we can attach it by paying more, right? Similar to how Databricks is there. So you can attach to Colab.
While installing PySpark, it's saying could not find a version that satisfies the requirement PySpark from version :none. No matching distribution found for PySpark.
This line you're saying?
Correct.
So Py4j should be there. Anybody is having any other issues? So this is the first line that you do. Okay, for me it is already been there. You have pip with you, right?
Yes, I guess. I have
Just check. Tell.
I have installed other libraries previously.
That's what, using pip, right?
Huh.
Then it should be. Do one thing, just copy that error, put it on the chat. I'll have a look. Okay, so fine. Now let's come back and let's understand a little more about Spark before we start putting our hands on the code, because there are a few areas still we need to understand. So we'll first
Is
read
there
this.
anything to like close or exit for Databricks webs.
Nothing.
Okay.
Just
close the tab.
browser.
Okay.
Yeah.
Okay.
Fine. Now, whenever we are working with Spark, one of the biggest or the most important approach of Spark, which makes it much faster, is its in-memory computation. Now, when we say in-memory computation, one very common question that we do encounter is, in any framework, the computation is going to be happening in the RAM. Correct? Agree, guys? Any computation that you take, any software that you open on your system, apart from discrete and discrete, if at all you are performing any computation, everything is going to happen inside the RAM, right? So then what is so special about PySpark's or Spark's in-memory computation, which makes it much more efficient? The simple, straightforward answer is, not only the processing is going to happen inside the RAM, rather the data is also going to be pushed inside the RAM. Now, if you remember a few minutes earlier, when we discussed about the intermediate output storage inside your Spark, if you guys can recall that, the intermediate output is also stored inside the RAM. That's not processing. So after you process, you got the output, which is your intermediate output. Now, generally, as per any other framework, the intermediate output has to be stored inside the hard disk, which will only make it much slower because disk read is involved. Wherein what your Spark is suggesting is, I'm going to even store that data in the RAM, which makes its process really faster. Now, since that data that I'm going to read resides inside the RAM, I don't need complex techniques like indexing or partitionings to retrieve them. See, generally, why we do have indexings and partitionings? You guys would have read about partitioning techniques in SQL, right? Or indexing. So why we need that? Optimization, right? Simple optimization, or to read the records faster because I have too much amount of data sitting under my disk. If I want to read them faster, it's going to take a lot of time. That's where indexing is needed. But then on contrary, in Spark, I'm going to keep them inside the RAM, especially the intermediate outputs and the data that I'm going to process. Of course, the final output is going to be in the HD, but then all the intermediate outputs are going to be inside the RAM. So if I want to reiterate it n number of times, I don't have to do a disk read. Rather, I can just do a memory read. So the need for indexing and partitioning basically gets cancelled out here. Rather, I can just focus on only the logic. I don't have to worry about optimizing my code, which is becoming one of the biggest advantage of your Spark. And there was one question on RAM will be of lesser space, how I'm going to efficiently use it. By default, Spark uses a lot of compression algorithms before it keeps the data inside the RAM. Now, that is one approach of efficiently handling it. That's not the entire way of handling or efficiently using the RAM space. But then the default compression algorithms helps to a greater extent in reducing the memory consumption inside your RAM. And developers don't have to spend a lot of time on optimizing the code because it's residing inside the RAM. And the analysis of data can be flexible and can be accessed within seconds, again, because of the RAM space. It is much more flexible. We have a lot of programming language options, right? And it supports simpler codes also compared to your MR. Okay, like we call it as one-line code. In Python, have you guys heard about Lambda? What is Lambda?
Yes, yes. Anonymous block of code that can have any number of inputs but can have only one expression.
Yes, right. So basically, can I call this as a function? Right? Because you give an input. It performs some operation, it generates some output. But tell me, in Python, we have another way of building function also, right? Now using DEF, suppose something like calculate some parameters I'm getting, some logic I'm
Yes.
writing, and I'm calling that function. Now,
Yes.
when this is a function, what does this do? Why this is also needed?
Like a single line code for it.
Simple, right? Very true. Single line code is basically what lambda functions are for. Now, when you have multiple lines of operations needs to be done, or a function needs to be called within, that is when we will go ahead with this mode of defined function creation, wherein when we have a single line operation, right? And most importantly, I don't have a need to reiterate it n number of times. I don't have to reuse them n number of times. See, here I need this function to be reused in multiple places. So I have to provide a name for that. So that whenever I call that name, the bunch of lines inside it will also get executed. I will be needing that 5 or 10 times down the line. But lambda functions are something which is not going to be reused, and it is also going to be operated in one just single line because the operation is quite simple and straightforward. That is where lambda functions are used. And the important thing is in Spark, all of your operations are lambda. That does not mean we are not going to reuse, or that does not mean everything is going to be achieved in one single line, or we don't have any complex operations. Now, the Spark architecture considers every single operation as a lambda function, and the result of it will be holding a name, right? That gets stored inside that. Now, you will understand this much more better when we start writing the code, right? Now, let's see some of the basic advantages and disadvantages so that when we start writing the code, we will also be aware of what are the things that we need to take care of while writing the code, right? Now, it is quite easy and not much of coding, which is a very good news for a lot of developers, right? Because all these codings are going to be inline function or one line function. Now, I'm not saying it is very, very simple, but then compared to multiple other MR related codes, your Spark codes is certainly simple. And increased processing power because of your in-memory computation or in-memory processing. You keep the data inside the RAM, you process the data, you store the output also inside there. It supports both batch and near real-time processing, which is again a great feature because in MapReduce, we don't have real-time processing at all. And it executes 10 to 100 times faster. Not in all situations 100 times, 10 to 100 times. It has a lot of data abstraction features. Rather, it will not call the data as a file, or it will not call the data as a variable. Rather, it encloses a file inside a data abstraction called RDDs, or data frames, which we will learn in a while. Okay, these are the advantages. Cons, when we discuss about cons, I will not call this as actually a con, but if you want to really pick it up, this can be one among that. It supports only near real-time processing and not full real-time processing, meaning, see, suppose there is a streaming platform, data comes to it, the data is going inside it, and you are receiving the data. Now, the data comes to you at a speed, let's say 50 Mbps. On the other side, you have to read and process them also parallel. Now, don't think the read and process will also happen on the same speed. No, certainly not. There will definitely be a lag. For example, when 50 MB is coming per second, I'm not going to read the entire 50 MB and process, probably 30 or even 20 or 25. Now there will be a remaining lag, right? On that particular second, suppose 20 MB is remaining, which is being lagged. which will be added again with the next bunch of records. So there will definitely be a lag because there is no way you can achieve 100% real-time processing, but the lag can be reduced as much as possible through your Spark. That's why it is called near real-time and not full real-time. Okay. And not much suitable for a large number of small files. This is with any distributed file system. Not only with Spark, even with Hadoop, this is the case, right? And obviously there is no inbuilt file system. Somebody even asked this question, right? So it should always be dependent on something. Yes, that's one disadvantage here, right? And expensive. Can you guys tell me why it is expensive?
Because the cost of the RAM is more than the disk. I mean, the quantum of memory cannot be matched with the disk. So we'll have to depend on the use case. We have to increase the RAM capacity. The initial investment for that would be higher than the disk procurement.
Perfect, 100%. Perfect, right? Because you're going to be dependent on your RAM. And obviously, as you said, the size of your RAM, the cost of your RAM compared to the cost of your hard disk, we know the differences, right? So certainly it's a one-time cost. When you're setting up your infrastructure, we need to make sure that the RAM space of every single node should be definitely higher such that it can handle that workload that we are carrying it out every single day. Got it? Great. Now we can work on multiple modes, which is again one of the biggest advantage, not necessarily only on top of a Hadoop cluster or only on top of specifically like AWS or anything. Now it can work on a standalone system, meaning you don't have a cluster at all. There is only one single system. And in that single system, I am having Spark. And in that single system, I'm going to, that is the only master, that's the only slave. That's what it is called as a standalone system. Not generally used in the industry scenario, probably for developing some basic codes or testing some basic codes, you can use. But I'm not finding in a lot of places we are using standalone systems. Now, it can also be used along with some other cluster managers. I think yesterday when we discussed about something on HDFS overflow, somebody asked this question on what do we mean by a cluster manager? See, simple. I'm having a cluster like this. So what we know as a cluster, there has to be a master, there are some slaves. Now the slaves will send the heartbeats to the master. Master will know the stat of every single slave. But don't you think the master gets highly overloaded because, see, it has to address all the incoming questions by different clients. Clients will come and give the file to the cluster, will request some file, will ask to run some program on file. So all these input requests your master has to manage. Parallelly, it has to manage all the heartbeat signals coming from all the slave nodes. It should take decisions when a data node is failed, what I'm going to do, over replication, under replication. And also, among all of this, before even assigning a job to a particular node, it should check the stat of that node also. How much memory is available? How much RAM space is it? So ideally what happens in a generic architecture, all these operations are single-handedly taken only by the master node, which is basically name node or a resource manager, right? Now to overcome that, in Spark, we have an in-between layer between your master and the slaves, which is nothing but your cluster manager. Now, what does this guy will do? Simple. all these slaves, when they are reporting to the master, they will send their heartbeat signals to the cluster manager also. Via the cluster manager, it's going to reach the master. Now, what this cluster manager will have? The cluster manager will have a complete idea. Okay, S1 is having 30% of HD, which is free right now, and probably 10% of RAM right now free, and its performance is somewhere around 75%. The efficiency of the CPU, the core handling, everything is going to be of around 75%. So this complete information about every single slave node will be available with the cluster manager. Now, before your master is assigning any job to the slaves, see earlier what happens in a generic architecture, master will directly assign some task to the slave by checking the stat of all this. Now going forward in your Spark approach, master will first communicate to the cluster manager, see, there is a job that we need to do. There is a reduction operation which needs to happen. You go ahead and decide which guy is free as of now, which node is free as of now, who is having enough RAM space. And it will leave that assigning job, the delegation job will be assigned to the cluster manager. So the cluster manager will decide based on the complete stat, it will delegate the jobs to the respective nodes. So that's the major functionality of a cluster manager. And that's where the name comes in place. Now, there are a lot of such cluster managers available, right? So Mesos is one, you have Yarn. So Yarn is basically called yet another resource negotiator. As the name clearly says, it negotiates the resources, right? So that's again another cluster manager. Spark by default, if you're going to read it from Hadoop, if you're going to make the file system of your Spark as HDFS, Spark can use Yarn as a cluster manager for that, which is highly compatible with Apache Spark, right? It is also compatible with a Mesos, which is again one of the another cluster manager services. Now, if you want to change your cluster manager, of course, it's a little tedious task. You have to get inside the installation files of your Spark, which is basically, there are a lot of XML files available at the back. We have to go and change the property there and restart your cluster. But it is very well possible. Got it, guys? Yeah. So it can work on all of these modes, which is very well possible. And the workload is basically getting splitted out here with the help of the cluster managers. Now, the plugins we already discussed, though it is initially invented in Scala, right now you can do this in multiple other programming languages. We don't have to separately download these programming languages because they also come along with your Spark installation. And many data scientists prefer to have PySpark compared to the other languages, obviously because of very obvious reasons, right? Libraries. And Py4j, which I already showed, was the library, right? Fine. Now, I'll show you how you can upload files inside your Databricks, right? Because I need to process some of the files. For that, I need to first upload them inside DBFS. So let's see that. Go to your Databricks account, okay? Make sure a cluster is running. Head into the catalog section. Go to DBFS. Right now you are having file store. Okay, no issues. Be inside file store itself. Click on upload. Can you see? Upload. It will give you an option of how I'm going to upload the file. So from where I'm going to read the file. So the target directory is going to be /file store. Whatever you're going to upload will be there inside that. Click on this space, drop files to upload. Go to the place where you have your file. So, any file, randomly pick up any file and you can load it. So I'm just taking this social media comments. So click on that. Okay, it will say yes, you have attached the file, and you click on done, right? And then when you click on your file store, you will be able to see that file present, right? This is a file that I have uploaded. Got it? Simple steps.
Yes,
Catalog,
okay.
DBFS, file store, or whatever path that you want. Click on that. Click on upload. This is a target path under which your file will be saved. So click on upload. Go to the path, whichever file you want. Pick up that file. It could be a CSV, it could be a TXT, it could be any kind of file. Okay. Click on upload. Done. You can locate your file present inside this. Okay, so this is in your Databricks. Pretty simple, pretty straightforward, not of a big deal. In Colab, because this is a first session, so I will show you parallelly. Going forward, I'll not show in both places, because once if you see, you will understand how things are here. Okay, so here there is no file system as such, but we need to upload the file on the Google server so that you can read it while processing. Okay, so here click on this folder. There is something called folder, no? Yeah, click on this. It will take few seconds to get visible out here. Click on this sample data. Here you can upload anything, or if you want to store it in an existing folder also, you can select. You want to create a new one also, you can create, upload. Okay, click on the upload icon. Transaction. Okay, because this is not going to be permanently saved, that's why there is a warning. No worries. Click on OK. You can find your file here. If you want to know the path, click on this. There is something called copy path. Okay. And then if you paste, this is a path where your files are stored. Clear, guys? Very basic ones. Just if you can spend a second on it, you yourself can easily understand what is actually happening in all these places. So this is the upload. This is a refresh. This is directly attaching a Google Drive here, because at the end it's a Google server, right? So directly you can attach, you can mount your drive also. Yeah, any questions here on the file uploading part in both the places? Initially, please, you also practice at least once in both, so that you get comfortable with that. And going forward, if I ask you guys to do some workaround or something, you can do in both places. Okay, I'll pause for a second. Please try this out in both places. Okay, all good. Fine. Now, the four different components inside Spark, which I have already discussed with you guys, right? Let's understand how these operations we are going to write. Of course, we are going to write some codes now. So, but before we are going to write some codes, how we can split these codes. So, all your Spark related operations are basically divided, they are basically nothing but APIs. You guys know what is an API? Can anyone explain? If you are aware on that. What is API?
Application interface.
What does P stands for? What does it do? What does an application programming interface do? Why it is needed?
Platform where another mobile devices or anything can get connected to and fetch data. Basically, it provides the port to get connect.
So it acts as an interface, can we say in that way? You send some request, you receive some response. Now there is an in-between place, which is basically communicating with the device, and whatever request that you're asking for is being provided to you if you are an valid account, right? So it's basically like it's a connectivity medium, right? To make it simple to understand, so I generally give this example for people who don't have any idea or haven't even heard about the term API. Now just imagine API to be a waiter in a restaurant. Okay, so imagine you're going to a restaurant. So you are ordering a food. Now you're not directly going to the kitchen and ordering the food, right? Rather, you're ordering it through a waiter, and the waiter will go to the kitchen and he will inform the chef what to do and what is the item that they are ordering for, right? So basically, the waiter is a person who is acting as an API here. Now, the person who is requesting is you as a customer, the person who is providing the service is a chef, and then basically, in between both of you, there access as a connection, which is basically an API, which in this example is a waiter. Now, similar to that in Spark, all your operations are basically going to happen through this API. So you are sending an API to your backend file system. The file system is going to process it, and the result is going to come back to you. Now, that result you are going to reuse n number of times depending upon your use case. Right? Now, the overall APIs are basically getting divided into two types. Right? One is called transformation based API, and another one is called action based API. Now, what do we mean by transformation based API? Now, have you guys used map filter functions in Python? See, going forward, I will be recalling a lot of
Yes.
functions from your Python because we are going to study completely through PySpark, through Python. So there will be a lot of involvement of Python. So if in case you feel like you need to refresh some of the Python concepts, please do that. Uh, because going forward, there will be a lot of Python involved. Right? So what does these map and filter functions do in your Python?
So map basically in a sequence, it applies a function to all the individual elements in a sequence.
Great. So basically, it helps us to transform the data. So suppose the data comes to you in one format. Maybe you want to append something along with that, each item, or you want to combine all of them and generate one single item, or you want to calculate and aggregate out of all of them. So basically, in all of these scenarios, what we are doing, we are accepting an input and we are transforming it into another. Now, all these APIs which are going to help you to transform that output is called transformation APIs, or they belong to the transformation API. Now we are going to learn a lot of such transformation API, map, filter, sort by key. We will learn something called group by key, reduce by key, collect. For so many are there. We will be learning all of them one by. Now, there are few APIs which are called action APIs. Now, what do we mean by an action API here is, okay, you perform some transformation. At the end of the transformation, you achieved a result and you want me to print that result out for you, or you want to view that result out for you. That is where action APIs comes in place. So some of the action APIs are collect, first, take is there, save as text file is there, save as binary file, save as sequential file. Yes, a lot of action APIs are there. Now, you should understand the solid difference between both of them. Transformation are basically APIs that are going to help to transform the data based on the business needs or based on your use case. Wherein action is to view or sometimes to store the final result into either a file location or you want to just simply view it on your screen. Both of those APIs falls under action APIs.
Hi Sylvia, sorry to interrupt. Just wanted to check with you. Is the class last till 12 o'clock or after that also? Because I have some office work to attend, so that's why I'm asking.
Well,
till 12?
12. Yeah.
Okay, thank you.
Yeah, so these are the APIs and these are the types of APIs and all the operations that we are going to perform through Spark or related or is going to happen with the help of these APIs. It can either be a transformation or an action based. So let's start with our very first one. Okay, see, you can save it out, the name of your notebook here. You can just cancel it out and type out a name which gets auto saved. So I will be, and all your saved workspaces will be available under the workspace section. Go into a workspace, okay, scroll down, whatever name you have saved, that name you will be able to find out here. Okay, so this is the one. Yeah, good that my cluster got detached. I'll show you what happens when your cluster gets detached. I think it's been more than an hour or so. So my cluster got detached automatically. Can you see this? Notebook detached, cluster not in a stable state. Can you see this is terminated? This is what you guys will also get when you keep your cluster not active for an hour or so, right? Simple. Please observe what we are doing. Okay, I'm writing some code here. Okay, just clicking on run. You don't have to go and go to the compute and restart it every time. Rather, from your worksheet itself, you can start it. That's what I'm showing you here. So click on the run icon. The new screen will come. See, what does it say? It says attached cluster is terminated. So this notebook is attached to a cluster which was terminated and you do not have a permission to restart it. Would you like to attach a different compute resource? Now, what does it mean by you do not have a permission to restart? Meaning we are using a community edition. So I know it is offering you 2 core, but the 2 core is not only fixed for you because it's a free edition. Whenever there are 2 cores available, whatever 2 cores are available at the time of your request, it will assign it to you. There is no permanent 2 cores always being fixed out for your account. That's what it's saying. You don't have a permission to restart that same core. Rather, I can give you 2 different compute cores. right? So I'm saying yes, select the resource, right? Now observe this, please observe this. Attached to an existing compute resource. So I have a resource name associated with me, which is called demo cluster. For you guys, it will be different, whatever name that you have attached. So I have a name already with me for my compute. All I need to do is randomly, I will ask my Databricks server, okay, go ahead and locate any two cores, attach it under this name, right? Please observe this carefully. Randomly pick up any two cores on your server, assign the two cores to me under this compute name, say demo cluster. That's why click on create, attach and run. You don't have to create any new resource, right? Because the existing one you can take and attach. Click on attach and run. It will take few seconds and then it will run. Can you see it now? Clear, guys? If in case your cluster is also disconnected, please try it out. Okay. Fine. Now we are going to start our code. Probably we are almost reaching the time end. So let's just see one single API as of now. Now, in your Hadoop cluster, when you start your cluster, we do have some background services always running because those background services are responsible for your entire operation, right? Now, the same way, when it comes to Spark, there is a separate service called Spark Context.
Just one doubt, Sylvia.
Yeah.
I'm getting an error message that you do not have required permissions to attach to cluster.
You are trying to start it from the compute section?
No, from the notebook.
From the notebook, you should be having. If you are doing it from the compute section, yes, you might get an error there. You might get that error because it's a community edition, it's a free edition. Directly starting from compute is not possible. But here though, it has to. What does the error say? Can you repeat?
Can I share my screen?
Anybody else is having an issue on that? I'm not sure whether they have changed anything new in the community too. You can share meantime.
Okay.
Please let me know if anybody else is also having that. Let me see.
Is the screen visible to you?
Yeah. Okay. You are in the community edition. Ranjan Jain's cluster is the name of the cluster. Okay, run it directly from the code here. You cannot run commands anyway. No, scroll to go to that drop down option under the attach resource. No, not here. Run the block. Okay. Yeah, click on that.
It's already selected.
And I just want to see, is there anything else apart from this cluster? Can you go to compute? Your attach is not visible, enabled, no, in that screen?
Yeah. It's always showing detach.
No, go to compute. You have one single cluster only. At times when you have more than one, it shows. Probably try to, close this and completely, see these kind of glitches to happen at times. So what you can do if in case it happens is just close it and re-log in again into the community edition. Even then, if you are having this, I would suggest you to completely delete that cluster, create a fresh cluster and start doing it. Then it should work.
Okay.
And directly starting the cluster from your compute section is not possible because we are in a community edition. This you cannot do. Okay, don't try. This is what I was initially checking. This we can't do. You can create a compute, but you cannot start it from here.
Okay, I'll
try it
try
out
after
and
logging in. If it doesn't work, then I'll delete the existing cluster.
Correct. Okay, let me know after you try that out.
Okay.
How about others, guys? Anybody able to restart the cluster?
Yes.
So your cluster was terminated and you are able to restart.
It was not terminated. It just stayed active.
Then why you have to again connect the cluster? Oh, okay. For all of you guys, it's still in the running state.
Yeah.
Great. Fine, then probably then we'll stop it here because you're already reaching the time. We'll not start with any new code as of now. We'll start with the next weekend. And please do finish this cluster setup part, everybody, whether it is Databricks or it's Google Colab. Please do finish that part and try to upload some files. You're not going to process those files as of now, but just check whether you're able to upload the files.
So the question is, just like in Colab, you can actually stop the runtime. So is it possible in Databricks?
No, it's not possible in Databricks.
So we just leave it like that, log out, then the next time we'll have to reattach.
Correct. Because see, when you are, if it is closed by you, even before the 60 minutes duration, it's going to automatically close that instance for you. So you have to reconnect it again. But if it is beyond 60 minutes, it's going to be automatically terminated. Okay. So in either ways, you have to attach it again. Yeah. Any other queries, guys? Try to create a fresh cluster and check branch. Yeah. Fine, everyone. If you don't have any other questions, we'll wind up for the day and we'll connect back again on the next weekend. Okay. Please do refresh on whatever we have seen so far.
Okay.
Thank you,
Thank
Sylvia.
you. Have a great week.
Yeah, you too.
Thank you.
Thank you, guys.
Thank you.
Thank
Bye.
you all.
Thank you.